Hi folks, what I'm planning today is to go through this tutorial where you have three blocks which are attached to each other and they follow a track that is shown here. This is for those people who may need to see this thing, and the fact that I may not be able to make it to class this afternoon. All right, first of all, I've modified the shape of the block so that they're a pseudo block, just like that, and they're identical. Therefore, I created one and inserted that as an existing component. But if that's a hassle, just go ahead and make three parts just like that. The strategy is to have a revolute joint between these edges, this edge, that edge, this edge, and this edge. And then you have 4 point curve joints between the curve of the track and these corner points. So let's first make sure that these sit in the right spot. So anchor the track, all right, and coincidence between this plane and the bottom plane here. Just lifts it up, okay, and then same thing with the other ones. So well, actually, maybe what I should do is to create these constraints between these edges first, and then do the shifting later at the same time. So coincidence between this plane and that plane, and coincidence between this edge and that edge, coincidence between this plane and that plane, and coincidence this edge and that edge. So these eventually become 4 revolute joints. Now I'm going to shift one of these to that side, and they all follow it. So coincidence between this edge and that edge. Okay, so it was easier than doing it individually. Great. Now we're going to go to the digital mockup, DMU Kinematics. Get the magic wand out. New mechanism number 1, auto create, okay, and let's check our joint. There should be 3 revolute joints, and oh, this one I think I forgot to do that. So let me delete this one. When I was doing this thing, I must have forgotten to select the axis probably, so I'll do it right now. So a revolute joint between this edge and the edge on the right, and this plane and that plane, and that will turn it revolute. Okay, when I did it and tried to use the magic wand, I probably forgot to select the axis. Now we're going to do point curve joints. So point curve joints between this edge and that point, and repeat this thing 4 times or 3 more times. This edge, no, sorry, not that one. Point curve joint between this edge and that point, and okay. All you need is one of them, because the 2 on both sides are actually follow each other. So track and that point, okay, and one more time, track and that point, that point. Okay, the degree of freedom is 2. First of all, one of these point curve joints, say the last one, we can make length driven. Okay, good. Now the degree of freedom is 1. So we don't know what to do, and it's not going to help to make all of these, length driven, so the degree of freedom artificially drop down to 0. The fact of the matter is that these things can slide, or actually they move along that track and being hinged about that edge, as if they have lifted off from the surface of the track. So what we should do is we should create a planar joint between the top surface of the track and the bottom surface of one of these. So for example, a planar between this and the bottom of one of these guys, and say okay. And notice that now the degree of freedom is 0, because this was point driven, and now the degree of freedom is 0. So let's see if this thing works. And you just move it around the track. You can see why I changed the shape so that it's slightly different from a block because they didn't want people to say, oh, these are interfering with each other. Well, they may be interfering, but from the kinematics point of view, it makes absolutely no difference. Now, there is one other issue that you should be careful. You might say, okay, would it have been possible to make a planar joint between the face of this block and the face of the track? And the answer is yes, but you will run into trouble. We'll see it. So let me delete this planar one, and show you what happens if we had actually created the planar between that face and this face. So planar between this face and that face, and we say, of course, mechanism can be simulated, but when we try to drag it, it goes up to a certain point. It doesn't go past that, because at some point, this should be in the same plane as the side of the track. But the side of the track here becomes curved, and that's why you cannot drag it further along the track. So just to convince you, let's do it again. I'm going to delete this planar joint and create a planar between the bottom of one of these. It doesn't matter. Last time I took this one, the bottom of this. I'll show you, it doesn't matter. I'll take the bottom of the middle one. Well, the surface of the track and the bottom of the middle one. Let's smush through it. And there. And of course, the mechanism can be simulated. And I bet we can drag this thing all the way around the track. Right there. Just like before. All right. Good luck. And I will work on the next video clip, which is the second problem that I want to do. All right, how do you stop this?